This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 10 problems from the June 2025 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Welcome to video number 4 in my series of June 2025 Digital SAT official exam problems. Before I get started going through these problems, I just want to mention a couple things that I mentioned at the start of all these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link in the description of the video and also in the pinned comment to the PDF file which has these 10 problems on it. Third, if you haven't done so already, please do check out the videos and the worksheets for basically Part 1, Part 2, and Part 3 of these June 2025 Digital SAT Math exam problems. And fourth, these have been compiled from various places, mostly from Reddit, a couple from Discord. So I've tried to recreate the problems as best I can. There may be some minor differences if you recognize some of these questions that you see on here because you took the June test, as compared to what I have written down. So just, be aware of that. And related to that, there are some problems that might have been multiple choice on the official test, but I have them down as free response. So if that's the case, there could be other alternate solution methods that you could do if a question is multiple choice because you have the answers in front of you. Whereas I'm solving it as a free response question. So please do keep that in mind as well. I think I've tried my best to understand exactly what the questions are asking and make them as realistic as possible. All right, so this first one, this is one of the trickier questions that I saw being reported. And basically what was going on is supposedly you were given a graph with a bunch of points resembling a quadratic function. And it gave you an equation which it said was basically, the model for that series of points. So I've, tried to reproduce that on this graph here that you see on the screen. All right, then, but the graph had one kind of outlier point way up here on the y-axis. Clearly not in line with all the other points. And then it said, okay, you make a new function by basically using the same set of points, but you remove the outlier point up here. And, what is true about the a and c values of the new function? In other words, what happens to the coefficients of the x squared term and then just the number term at the end when you do that? So I will tell you. And then the two options here were obviously a is going to increase. I mean, it says greater than 0.07, but really it's just a is going to increase when you do that, and c is going to decrease. C less than the given value of 6.07. All right, so I'll tell you the answer is C. At least that's what I believe. It's both. Both of these will be true for the new function after you take out the outlier. And the reason, first I'll kind of explain the theory behind it, and then I will show you a specific example in Desmos just to confirm this. So the reason that both are going to be true, let's start with C. Okay, so if you take away this outlier point up here for C, and even if you don't add in the actual, where the actual point on the true quadratic, model would be, say like down here, even if you don't do that, now if you go through, okay, and you want to draw like the best fit line through all of these points, let me just pick a different color here. Sorry, not best fit line, best fit curve, essentially. Notice what's going to happen is it's going to be pulled down. Essentially, now the best fit curve is going through all of these points which are on the same model, so it's going to look, something like this. So C, which is really the y-intercept value, where it crosses the y-axis, is going to go down. It's going to decrease. Okay, so number 2 is going to be true for sure. Like that should be obvious that this outlier value way up here is pulling, ends up pulling up the y-intercept from where it otherwise would be. Okay, now the question is what happens to A? So it's not easy to see. It's not apparent from like, my just rough sketch or estimate here. But basically what's happening is when you add this outlier point, that's shifting the graph up. It's basically pulling the graph up from where it otherwise would be. It's going from the green to the blue. When it does that, it forces the graph to widen in order to hit the points. Like if you put an extreme outlier, right, and you put it like way up here, it would force it, to widen a lot more, and it would be a lot more obvious to see as compared to what I have on the screen here. Therefore, if you get rid of the outlier point, it is going to narrow. Basically, as it drops down, then to hit these points, it's actually going to be narrower than it would be up than it was on, like, looking at the blue curve here. Since it's going to be narrower, that means the A value is going to be larger or increase, so that will be true as well. So I believe the correct answer to this one should be letter C, that both are true. Now, here is an example in Desmos just to demonstrate this. All right, so what I've done here is I've basically done out two tables of values and two graphs. Okay, for the first one, which is what you see on the screen here, I put in a bunch of points. Okay, all of these points are on the quadratic function x squared plus 1, except for this 0, 6, this outlier point right here, right? Everything else you can see is like pretty much in line, everything else is in line with that function. I chose, again, x squared plus 1. So now, I did a quadratic regression, and here's what I got, all right? So notice the A value is 0.965, the C value is 1.874. So now, what I'm going to do is I have a second set of points and a second regression. So I'm just going to turn those on. So notice the points are basically all the same, except for basically notice, like, so see all the red points are all the same. It's just there's the one green point that's not included. And now when I turn on, the regression, so notice what happens. First of all, you should clearly see on the graph that the C value goes down, it decreases, right? Here it is in the initial 1.87, here it is down at 1, okay? So removing that point, removing the 0, 6 point, the outlier point, causes the C value to decrease. So number 2 is clearly true. Now, what happens to A? So originally with the outlier, it's 0.965, blah, blah, blah. Now, without the outlier, it's 1. So the new A value is larger than the old A value. I mean, it's not necessarily that easy to see from the graph because the numbers are still pretty close. You're talking about a 1 versus 0.965. But the A value has increased as well. So this is just basically visual confirmation that when you take a series of points and you have one outlier value, okay, and we take the A and C values for that model, and then we take away the outlier value, then you can easily see that the C value will decrease, will go down. It'll be, so in other words, for the new function, which the red is basically the new function. So now you can see that for the g of x, which is the new function, which is the the red points here, the red curve, that both c has decreased and the a value has increased. And I will include a link to this specific graph on Desmos so that you can go look at this and access this, on your own as well, and just check out the points and confirm the points. All right, so let's move on to the second question now. So here we have basically, right triangle trigonometry question. You're told that we have this right triangle ABC. B is the right angle. And we're also told that side BC is 6. And the hypotenuse, which would be side AC here, across from angle B, is 19. The area of the triangle is equal to k cos A, where k is a constant. What's the value of k? All right, so there's two different ways you could do this. The quickest way, the easiest way, is to say, okay, the area of this triangle, which is 1/2 base times height, is 1/2 times the base, which is 6, times the height, which is AB. The side AB, we don't know what it is, but that's fine. You actually don't need to know its value because you'll see it'll cancel out. Now that's equal to k times the cosine of A. What's the cosine of A equal to? Well, it's just adjacent, which is AB, over hypotenuse, which is 19. So we can just replace this with what it's equal to, which is AB over 19. Now what happens is the AB's cancel out. 1/2 times 6 is 3, so we get 3 equals k over 19. Just multiply 19, both sides by 19, and k turns out to be 57. So that's the correct answer. That's what you would type in or fill in. Now, here is an alternate way that you could do this problem. Again, this is, I would say, a longer way, more complicated way, but it's, slightly different way to think about it. So first, you could find the value of side AB. Just do Pythagorean theorem. 6 squared plus AB squared equals 19 squared. If you do that, it's going to be the square root of 325. However, I would probably just do it in Desmos and just get the the decimal value. Let's see here, whatever, I'll just call it b squared. Okay, so that's where it is. That's where it is, 18.027, blah, blah, blah. Okay. So now that we have that, you can say, okay, the area is equal to 1/2 times that value. You can just do it in Desmos, times 6. So 1/2 times b times 6. All right. Just bring this up here. Okay, so that's the overall area of the triangle. Now, the other thing that we're going to do here is basically just calculate the value for cosine of A. So in other words, it's root 325, but again, if you did it in Desmos, it's just going to be, so in other words, cosine of A is going to be root 325 over 19. But if we just go back to Desmos, all I can do is just take the decimal value for the root 325, divide that by 19. Okay, so this is equal to cosine of A. So I'll call this whatever. I'll call this capital A. All right, and now we just set these two things equal. So I'll call this little a for area. So now basically what I'm going to do is I'm going to say the area of the triangle, which is this number, is equal to k times the, oh actually never mind, we can't do that because we're going to be doing regression twice. So what we have to do is, okay, instead we have to take this and we have to set this equal to k times b over 19. All right, except that is not working for us. It's given us the correct value of 57, but it's not feeding in the right b value. Okay, so I guess actually the way we would really want to do this is we would want to solve this for k by dividing by cosine of A. So we would want to, what we want to do is we would want to take the area. Let me see if I can do this right. Okay, so we got 1/2 times the base, which is 6, times the height, which is the b value. So that's the area. And then we want to divide this by cosine of A. And the cosine of A is b over 19 there. And this is basically equal to our k value. I've got the area of the triangle on top that's being divided by the cosine of A. Cosine of A is adjacent over hypotenuse, which in this case is this b from up here over 19, and it works out to exactly 57. That's what we want. So this is how you'd have to do it, because you can't take one value from a regression statement and carry it over and use it in another one. That's the problem, or that's the issue, basically, that I was running into. So again, that's an alternate approach, an alternate way to think about this. I think the first way is much simpler, much quicker, much easier, but if you don't recognize that or don't see that, like, that's fine. You can do it this way as well. All right, let's look at the next question. Here we have a cube. They give you the volume. They want to find the surface area on all 6 faces of it. So if the volume is 91,125 cubic centimeters, that's just equal to the side length cubed, you know, length times width times height, but they're all the same, so it's just s times s times s, let's say. So you cube root both sides. Side length should turn out to be 45. Let's just go to Desmos to confirm. Cube root. Yep, there it is. Side length is 45. Okay, then to find the area of one face, we're just going to take 45 and square it. So again, that's going to be the area of one face on the cube, 2025. And then, of course, you have to multiply this by 6 to get all 6 faces. 12,150, that's your answer. That's what you would type in, and that's pretty much all there is to this problem. All right, now let's take a look at the top of the next page, problem number 4. Here we have another right triangle where we have angle B is the right angle. I'm actually going to put C at the top and A at the bottom. The reason is because we have point D here on the hypotenuse AC. We have point E here on this side BC, such that, you know, DE is perpendicular to it, like this. Side AB is 7.2 inches long. The ratio of BE to EC, 3 to 5. So for example, 3x, 5x, let's just say for now. All right, what is the length of line segment DE? Okay, this is a basic similar triangles type problem. Essentially, what we're going to do here is, it's like, you separate the top one, 5x, you know, whatever, DE we don't know, we're going to solve for it. All right, we got the bottom one here, 7.2 A, B, C. Right angle. So here's the thing. Notice, with this ratio, knowing that the ratio of these two parts is 3 to 5, that means that the total overall, you know, would be 8. Or, I mean, not necessarily 8. We don't know the specific values, but we know that the ratio of the corresponding sides from small, you know, to large is 5 to 8. In other words, CE to CB is a ratio of 5 to 8. So now, because of that, those are corresponding parts in a similar triangle. Therefore, the ratio scale factor between them is going to be the same as from DE to AB. And we know AB is 7.2, so we just fill that in, and now we can solve for it. So we just cross multiply, you know, 5 times 7.2. What's that going to be? Not quite 40 something. Oh, just 36. So 8, you know, times whatever DE is 36. You divide by 8. DE, the side length, is just going to be 4.5 inches. So you could grid in 4.5. You could technically also grid in 9/2 as well if you wanted to use the fraction form. Either would be considered correct, but this is how you could solve this specific problem. All right, next up, this is a number 5. This is a repeat question. This first appeared way back, I think in May, at least May, possibly earlier, of 2024. Essentially, you have a quadratic function, and you know what they're telling you is that when x is 18, the function has a positive value. Then at 21, it has a negative value. And then at 24, it's back to a positive value. So that tells you that it crosses somewhere between 18 and 21 and 21 and 24. And specifically, the values have to be integers because that's given in the problem. So your possible values for A are either 19 or 20. Possible values for B are either 22 or 23. So to get the possible values for A plus B, you just add up all these combinations, right? So you got 19 plus 22, 41. 19 plus 23, 42. 20 plus 22, 42, already have it. 20 plus 23, 43. So this one has three possible answers, 41, 42, 43, and either of those would be accepted as correct. Okay, let's look now at question 6. This is, again, another repeat question. This appeared, again, sometime last year, 2024, in the summer, I believe. So what's happening is you have the same number of predators and prey. And I'm just going to work this one out using picking numbers. I think it's so much easier to use actual numerical values. So there are 100 of each to begin with, I'm just going to say, all right? Prey increased by 2,800%. So that means you're basically taking the original, multiplying it by 28, the decimal equivalent of 2,800%, and then adding it. So we're going to get 2,900 for predators, and then for prey, predators increased by 390%, so that's taking 100, multiplying it by 3.9. You're going to add it. You are going to get 490. So let's go through Desmos and just do some of these calculations. So we have, okay. So basically we're starting with 100, right? And then we're adding 2,800% of it. And we're doing the same thing for 390%. Okay, so I'm going to call this one, I'm going to put Y for prey, whatever, T for predator, just picking some unique letters. Okay, number of prey is what percent greater than number of predators? All right, so let's just translate this. Number of prey, 2,900, is equal sign. What percent greater than number of predators? So that means we're taking the 490 and we're saying what percent of that, greater than that, more than that, increased by that, do we have to do in order to equal that value? So the equation we're going to set up is the 490, the original amount, plus then this is the percentage increase. This is the what percent greater than part of this. So this equation, if you just go ahead and solve this, you subtract 490 on both sides, we get 2410 equals 490x. X is going to come out to, I think, 4.9184. So essentially we've got y equals t plus x percent of t. So we could do it this way. No, it's not going to, no, that's not going to work properly. All right, so let's forget that. Just trying to see if there's if we do regression. There we go. So notice if you type it in here like this, essentially 2,900 and then regression 490 plus, whatever, p percent, k percent, whatever thing you want to use of t. This is actually giving you the percentage right here. This is not giving you the decimal equivalent. This is giving you the percentage because I put the percentage sign in the value. So this is the answer right here, 491.83673, blah, blah, blah. So if you're going to round this to the nearest percent, again, solving for a decimal value, it would be, 836, blah, blah, blah. And then as a percentage, 491.836%. rounding to the nearest percent, 492. That's what you would fill in. You typically do not fill in the percent sign, just the actual value itself. Okay. This is the main approach I would take for this. I don't know if, besides like the work I've shown here in Desmos, I don't know if there's also an easier approach to take in Desmos, besides, you know, just like doing the actual calculations and then like setting up, say, a little regression statement or equation here. But if you know of it, feel free to leave it in the comments below. All right, next, let's take a look at this one at the top of the next page. So this is not a repeat question. This appears to be a brand new question we haven't seen before. Basically, you're given two x-intercepts. So by the way, this and this, these are supposed to be lines indicating that, like, you know, the one is repeating forever. And you're told solutions of this form, m plus n over root n over 3. You know, what's the value of m plus n? So the first thing to notice is that if you take your two solutions here, x-intercept solutions, roots, all the same thing, and you add them together, so the 1.9111 plus negative 5.911, blah, 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 you will get negative 4. And we know that the sum of the solutions is equal to negative b over a, you know, shortcut formula. Therefore, what you can do now is basically determine that 2m, one other thing you have to do, you have to add, like, okay, you have to take this solution, m plus root n over 3, realize there's going to be a second solution, which is m minus root n over 3. And if you add these together, the square root n parts cancel out. And actually, let me just rewrite this because I didn't write this correctly. This should be like this. Okay, you have to add these two parts together too. So when you add the solutions in this form, you get 2m. When you add the numerical values, you get negative 4. So it's actually, those are actually the things that you set equal to each other to solve for m. It's not the negative b over a thing. We're not using that here. So m is equal to negative 2. Now, to get n, I mean, basically you could just, you know, take this and set it equal to, you know, negative 2 plus root n over 3. You could solve this by hand, with, I mean, obviously using a calculator, but like, you know, move the 2 over and then times 3 and whatever. But I prefer just to go to Desmos and just solve this equation, you know, in Desmos using regression to get the value. I type it enough times, notice then it recognizes the fraction, you know, the 86 over 45 part. Okay, so we want, so let's just do that. Let's 86 over 45, negative 2 plus square root n divided by 3. So this is the value you get for n. So now we've got negative 2 plus n, 135.67. So I'm not sure exactly how this question would be asked or worded. I just made it such that the value would be rounded to the nearest whole number. So therefore, the correct answer for those instructions would be 136 here, because the 6 to the right of the decimal would round the 5 up. So to this version, I get the correct answer as 136. Now, there is actually a quick and simple and easy way to do this in Desmos. So here is the approach or the strategy that you would take. Basically, I'm going to set up a system of equations using regression. So I have my two solutions, okay, here. and I know that the first one is equal to 1.91, and you have to like, just whatever, put a bunch of ones there. I know the second one is 5.91, and I just have to put a bunch of ones. And notice eventually, once you type enough ones, the values aren't changing anymore. So that, it gives me m, it gives me n, and so m plus n right here, 135.67, therefore be rounded to 136. So that's how you could do this entire thing in Desmos, again, by just setting up a system of equations, each like general form equal to the specific value that you're given. Okay, so for this next problem, number 8, this is a repeat question. Definitely seen this on Blue Book tests and on previous exams as well. You have a system of equations. You're told it has no solution. You want to find the value of p. So if you want to do this by hand, the way that I would do it is I would move everything over. Basically, I would get everything into slope-intercept form and then equate the two slopes. So on the top one, that means adding 7/8 y to both sides. So you get 14 y over 8, and then adding the negative 5/8, adding 5/8 x to both sides to move that over. And then I would go ahead and I would multiply by 8 over 14. Cancels everything out. And we're going to get 5/14 x. And then here, let's see, we're going to get 4 goes into 14. That's a 2, that's a 7, and that's probably going to be it. I think it's going to be 16 over 49. I mean, the number itself doesn't really matter. So on the test, you would not necessarily want to waste time, doing that. But let's just confirm. 4/7 times 8 over 14. Yep, 16 over 49. Okay. Then on the bottom one, just subtract 15/4, and then you're just going to divide by, so 7/4 minus 15/4, that's going to be negative 8 over 4. Get rid of all this. And then just divide by p. P down here, p down here. Y equals positive 5/4 5 over 4p x minus 2 over p. Again, that part does not matter. Okay, so now you can set the two slopes equal. 5 over 14 equals 5 over 4p. Notice these top numbers are actually equal. That means the bottom's equal, so you can really just go 14 equals 4p. P equals 14 over 4, or 7 over 2, or 3.5. So the correct answer, 3.5, 7 over 2. You could technically, believe, do 14 over 4 as well to get your answer. If you didn't want to, you could just cross multiply this also. You get 20p equals 70, and then just, divide by 20, and so on. 70 over 20, 7 over 2, 3.5, same thing. All right, but let's take a look now how you could do this in Desmos. So what we can do is we can go ahead, and you still have to do a little work for this method. Basically, you want the you want the ratio of the x coefficients to be the same as the ratio of the y coefficients, top to bottom, top to bottom. So that means you need x and y on the same side. So if you want to do it in your head, if you want to do it manually, either way is fine. Okay, so for the first one, top equation, we would again move the 7/8 y over to the left side, right? So we've got 7/8 y plus, and you don't have to combine them for this method. Minus 5/8 x equals, whatever. All right, so x coefficient on the top side is going to be negative 5/8. Bottom equation, we need x and y on the same side. It doesn't matter how you do it. I'm going to subtract 5/4 x over. So I've got negative 5/4 x plus py equals, the numbers we don't worry about, we're not concerned with. We just need the x and y terms on the same side. So the x coefficient bottom equation is negative 5 over 4. All right, now on the right side, we need the y coefficient from the top, which would be 7/8 plus 7/8, and we can just leave it entirely like that. And then on the bottom, the y coefficient is just p. So once we type this all in, notice we get 3.5. Again, you could type it down here, 7/2, 3.5, same thing. Okay, so this is how you could do the problem entirely in Desmos. And if you want more practice with this, if you want to see a more kind of a in-depth explanation, check out my Ultimate Desmos Guide to Digital SAT Math. It is, I believe, it's part 9. I'll have a thumbnail of the video on the screen here where you can go check it out. All right, next up, question number 9. This one on the test supposedly mentioned something about trees, but again, I haven't seen a copy of the problem, so I don't know how trees were involved. But the whole idea was you were given the side length of something, and then you were also given the total weight. Technically, this should actually say mass, not weight. So I will correct that in the worksheet. It should be mass. It should not be weight. And then you were asked to find the density. So all we have to do here, so I just basically, I have a cube, side length is 2. Therefore, for its density, that's the mass divided by the volume. So the volume is just going to be 2 to the third, 2 times 2 times 2. That's going to be 8. The mass we are given, it is 3.52. So for this question, all you're doing is just dividing those two numbers, 3.52 divided by 8. That's going to be the density of this object, 0.44. Basically grams per cubic centimeter, but the units don't matter. You would type in 0.44. You could technically also type in 0.44, or let's see, is there a simplified fraction? Yeah, just 11 over 25. So 11 over 25, that would be acceptable as well. All right, let's look at the last question here, number 10. This, again, appeared to be a brand new question, not a repeat. You're given this equation with x and some n's, and you're told to find the value of x to the n. So what I would do is, you're going to solve this by hand. The approach or the method I would take is basically, this 2n root means that the entire expression on the right side is raised to the 1 over 2n power. So the way you would cancel it out, you would raise both sides to the 2n power. You had x to the 2n equals, and then this and this cancel, 2x to the n plus 35. And then move your terms over. Now you basically have what looks like a quadratic type function, right? Because you can factor this. It's going to be x to the n, factors of negative 35 that add up to negative 2. Well, it's negative 7 and plus 5. Therefore, x to the n equals 7, x to the n equals negative 5. This is the only correct answer, and the reason is, I believe, because of the requirement that n is a positive integer constant. You're going to run into issues with the original problem here where you have the root if you let x to the n be equal to negative 5. So I believe the correct answer for this one should only be 7. It should not be negative 5. However, let's see how you could solve this in Desmos. So go ahead, bring up Desmos here, and basically I'm just going to type in the given equation, except do it as a regression statement. Type nth root to get a blank root where I can put the 2n in there. Use x1 for every x, of course. Okay, now what I'm going to do is I'm going to set a value for n. Okay, notice here when I set n equals 1, it goes to 7. I'm also going to start it at 1 because we're only looking for positive integers, and I'm going to set the step to 1 so that way when I move the slider, it is only going between integer values. So notice, if I start with the 1, I happen to have the 7 answer I was getting. However, you move here, the values change for x1, right? But remember, we're looking for the value of x to the n, or in this case, x1 to the n. So if you notice what happens, even as I move the n value, x1 to the n remains unchanged. It's still 7, even as I go from 1 all the way up to 10. So this is just confirmation that 7 is the correct answer. This is how you could solve this problem. Again, completely in Desmos. You can see it's very quick. It's basically just typing in the equation as a regression statement, adding a slider for n, and then just moving it to confirm that yes, x1 or x to the n will equal 7. All right, so I hope you enjoyed this video on the June 2025 SAT math problem set number 4. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, if you have questions or comments or alternate solution methods, please leave them in the comments below. And if you haven't done so, check out the videos and worksheets for Part 1 and Part 2 and Part 3, for 30 additional practice problems from the June 2025 Digital SAT Math section. And finally, if you're looking to improve your Desmos skills, please check out my Ultimate Desmos Guide to Digital SAT Math. It's up to over 4.5 hours now of tips and tricks and many advanced use cases of regression. There are almost 60 practice problems to help you master Desmos and ace the Digital SAT Math section.